Good morning. Today we will discuss about loop again in the very much detail. Up to till today we discuss about that how to find the factors of a given number, how to find the factorial of a given number, how to find that the given number is prime number or not, how to find the prime number between the given range. That all we discussed till today. Now today I want to show you that how we can find that the sum of the given digit. For example, I have the number is, for example, 3876. Now I want to make the sum of each digit. So how we can do the sum of this digit? So sum of digit will be 3 plus 8 plus 7 plus 6. So you can say that the sum will be 24. 3 plus 8, 11 plus 7, 18 plus 6, it will be 24. Now how to make the sum of each digit? So very simple. This is a decimal number, student. And whenever you have a decimal number, you just need to understand what? That each and every number has a power of 10, right? Let me give you the power of 10. For example, suppose this is the number that is 3876. Now I want to find it out the power of 10. Then you can say that 10 raised to 0 multiply by this number, right? And 10 raised to 1 multiply by this number. 10 raised to 2 multiply by this number, and 10 raised to 3 multiply by this number, and make the sum of all this. You will get this particular number. How we can do this? Let's see. 10 raised to 0 means it is a 1. 10 raised to 1 means it is a 10. 10 raised to 2 means it is 100. And 10 raised to 3 means it is 1000. Now 1 into 6, you will get a 6. Now 10 into 7, you will get a 70. Now 100 into 8, you will get 800. And 1000 into 3, you will get 3000. Now whenever you make the sum of this number, you will get that 3876. So it is meaning is what? Each and every number is decimal number, and you can say that the base of this number is 10. And that is the reason why whenever you multiply with the power of 10 to each digit, and if you make the multiplication and after if you do the sum, you will get exactly the same number again and again. Now the thumb rule is what? How to get this particular number, how to separate all this number. Then it is very simple. Whenever you write like this 3876 by 10. So whenever you divide your number by 10, then you will get the last digit in your remainder. So it will be 3870. So I am getting here 6, and 6 is the remainder, right? So whenever you get the remainder, so how we can write the code for this? Very simple. Remainder is equal to number modulo by 10. So whenever you write remainder equal to number modulo by 10, you will get 6, right? Now you can write a one variable over here. That variable will be sum equal to 0. You can simply write sum plus equal to remainder. Now what is the benefit? That the remainder value, that is 6, will be added in sum. So now my sum will become 6. Now I need to perform the same operation on this number, that is 387. So how we can do? Very simple. You can repeat the same task again, that is divided by 10. So 387 divided by 10. So now whenever you divide on this particular number, right? And suppose if you divide this, then you will get the remainder over here, that will be 7. So I need to do the remainder again, but before this, I need to divide that number. It means the 387 should be divided by 10. So I can write here number equal to number divided by 10. So what is the biggest benefit? The number is actual number is 3876. Modulo 10, you will get 6. Now number is what? That is 3876 divided by 10. So 3876 divided by 10 will give me 387. Right? So I am getting 387 in this number. Suppose if I run this again and again, so up to which step I need to do this? Very simple. Until and unless I get this divisor, that is the number, right? That is 0. For example, if you divide over here, then you will get the 8. It means I am getting 6 first, then I am getting 7, then I am getting 8. Now I have 3. So I can write here 3 divided by 10. So the value will be 3. In short, I need to do the same thing until and unless my number not become the 0. So here you can write a while loop that while number not equal to 0. While number not equal to 0, if you run this particular thing, then you will get what? If you run this particular loop, then you will get what? You are getting every time reminder, and that you are adding into some variable. So now my sum will do what? 6 plus 7, that will be 13, plus 8, it will be 21, plus 3, it will be 24, and whenever you print at the last, you will get the sum of the digit. So very simple, whatever you pass from the user, you can get, right? But for that, you need to just do the paperwork first, and then you can do the same thing in the code block. So what I need to do? Very simple. I need to just declare the variable, for example, integer number. I need a reminder. Then I need a sum variable is equal to 0. So I will ask to the user that enter any number. So user will enter the number. For example, the number is ampersand number. Suppose the number is 3876, then what we will do? Simple. While number not equal to 0, so the loop will be run up to the number will become the 0. Then you can simply write here remainder is equal to number modulo by 10. Then you can simply write sum plus is equal to, that is remainder. Then you can write number is equal to number divided by 10. Why 10? Because it is a decimal number. So here you can simply print sum of digit is equal to percentage D, and you can print some variable. Now here you can just click on build and run. Whenever you click on build and run, now it will ask you for the number. Here you can provide the same number that we traced on the paper. The number is 3876. Now here you can check that the sum of digit is equal to 24. What it is doing? Simple. First the number will be divided by 10. So number modulo by 10. So I am getting a 6. Now 6 is added to some variable. Then it will simply do the number equal to number divided by 10. So my number will be replaced with the 387 now. Now 387 will be again divided by 10. Why? Because I am doing the modulo. So in short, modulo will give me the remainder and divide will give me the quotient. Right? So this is the way you can find the sum of the digit. Now people may ask you that I don't want to find the sum of digit. I want to find the reverse of the given number. So how we can convert this particular program into reverse of given number? So whenever you want to do a reverse of the given number, the logic will be almost same. The logic will be almost same. Why? Because we are getting each and every digit by modulating the number. Whenever you get this number, right? Now the task is very simple. Suppose if you want the reverse of that particular number, then how we can get the reverse of that particular number? Now, I have a wonderful logic for that particular thing. For example, Whenever you divide any number, you will get first what? That will be 6. Then you will get what? 7. Then you will get what? 8. Then what you will get? 3. Now, I want to convert this into whole number. So, what is the logic to convert the number? So, very simple. You first get the remainder. So, you can get the remainder is equal to number modulo 10. So, whenever you write number modulo 10, you will get the last digit and that will be 6 first. Right? Now, we can write here that is a reverse multiply equal to 10, or you can say reverse equal to reverse multiply by 10 plus remainder, right? So what is my remainder? Remainder is 6. Now you can initialize your reverse variable is equal to 0. Now anything multiplied by 0, the value will be 0. So 0 into 10 you will get 0. 0 plus remainder 6. So your reverse will store the value will be 6. And then you can write number equal to number divided by 10. You can run this particular thing until and unless your number become 0. Now here you can trace, is it working properly or not? For example, see, my number is the 6 first. So what we can do? Reverse is equal to 0. So 0 into 10, it will be 0. Plus remainder, it will be 6. So my reverse value will be equal to 6. Now what I need to do? Very simple. Reverse is 6. 6 into 10. So it will be 60 plus remainder. So remainder is what? That is next time 7. So now my number will become 67. Now again if you run this particular thing, then reverse equal to reverse multiply by 10. So 67 into 10 you will get 670. And 670 plus a remainder that is 8. So you will get 678. Now you can run again, that is reverse equal to reverse multiply by 10. So 678 multiply by 10, it will be 6780 plus remainder it will be 3. So 6780 plus 3 and you will get 6783. And here you can just verify the given number is 3876 and the reverse number is 6, 7, 8 and 3. The formula is very simple. You just need to do what? Reverse equal to reverse multiply by 10 plus remainder. So very simple, instead of sum, I just need to write here that is reverse is equal to reverse multiply by 10 plus remainder. So now I don't need a sum, I need a reverse. So now I just need to replace this particular thing, that is reverse of the number is equal to percentage D, and you can print your reverse. Now what is the biggest advantage? That your number will be reversed. For example, suppose if I am passing here that is 3876, this is exactly the same input that I did on the paper, and that is 3876, and here I'm getting the reverse that is 6783, the same number over here. What I did? Simple. I just first get the remainder, then I multiply reverse with the 0. Reverse variable is 0. So 0 multiplied by 10, it will be 0 plus remainder, it will be 6. So I'm getting first 6. Then 6 multiplied by 10 plus remainder, so 67. 67 multiplied by 10 plus remainder 8, so it will be 678. 678 multiplied by 10 plus 3, so it will be 6783. So very simple, you can get the reverse of that number using this. But problem is what? Whenever you find the reverse of any number using this, and if you are dividing your actual number, then your actual number will be lost. Why? Because see what happened over here. If you see carefully, then your actual number will become the 0. See here. This is my original number, that is 3876. I'm just dividing by 10, dividing by 10, dividing by 10, dividing by 10. So my actual number becomes 0. And what I'm writing here, while number not equal to 0. It means my actual number will become the 0. Now suppose if I want to print here that the reverse of the given number, reverse of the number percentage d is equal to percentage d, and I want to print the number over here. What if I want to print the number? Suppose if you are printing the number and if you are passing the same number, that is 3876. Now here see that the reverse of the 0 is equal to 6783. It means my actual number is lost, right? So suppose if anybody asks you that the find out that the given number is palindrome or not. Now what is palindrome? Given number is palindrome or not, that is the condition that the reverse of the given number is equal to the actual number. For example, see here carefully. Suppose if I am passing the number that is 1881. Now reverse of this number is equal to actual number, right? So if the actual number and the reverse number both are same, you can say that the given number is palindrome. Now I want to find it out that the given number is palindrome or not. So now the problem is what? See, here my actual number is lost, right? So what I need to do? Very simple. You just need to store your number into temporary variable and you need to save your actual number. So here you can create the variable temporary is equal to number. So now instead of number not equal to 0, you need to run your variable up to temporary not equal to 0. Instead of remainder, you just need to write temporary modulo by 10. And instead of number divided by 10, you need to write temporary divided by 10. Now what happened? Your actual number will be as it is. And if you run this particular program, now if you run this, definitely you need to declare the variable that is temporary. Now, if you run this particular program, now you will get the idea that whenever you pass 3876, the output is 6783 and your actual number is already there. Why? Because what we did, I just assign my number to the temporary and then I just run the loop up to my temporary not become the 0. It means my original number is as it is. Now I want to check that it is palindrome or not. Then you can write if number equal reverse. It means if the number and reverse both are same, then you can simply print the message that the percentage D is palindrome number. And here you can print the number. Else you can print the message that given number is not palindrome number. Now you can run the same program again. Now what is the wonderful thing? See, whenever you pass any number, for example 3876, it will give you the reverse of this number is 6783. And it says that the 3876 is not palindrome number. Yes, it is correct. It is not palindrome number. Now if I am passing here 1881, then it will says that the 1881 is the palindrome number. Why? Because the reverse of this number is equal to actual number. So once you understand how to cut the number, right, how to get the each and every digit from the number, then you will be able to find the sum of the digit, you will be able to find the reverse of the number, and even you can find the palindrome of the given number. Now I want to check that the given number is Armstrong number or not. So whenever you want to check the given number is Armstrong number or not, how we can do that particular thing? So we need to first do that particular thing on the paper, right? What is Armstrong number? Very simple. You first need to get the number which is Armstrong. For example, 153. Now you need to cut each and every digit, so you can get the you can get the last digit and then all digit you can get by moduling 10. Now the cube of this number, so 3 cube will be, that will be 27. Cube of this number, that will be the 5 cube will be 125, and the cube of this number, that is the 1. So 1 plus 125 plus 27 is equal to 153. So how we can do this? Very simple. First we need to cut the digit. So how we can get the digit? Very simple. Remainder is equal to, that is a temporary modulo by 10. What is temporary? I already told you. Simply do this. Temporary is equal to number. So your number will be assigned to temporary variable. Now what we can do? While temporary not equal to 0. So we will run this particular loop until my temporary not equal to 0. I am getting the remainder over here, right? And that is remainder, for example, that will be 3. Now I want to just take a one variable over here, that is sum is equal to 0. What I will do? Sum plus is equal to, so I will add the value into sum, and that is what? Sum plus is equal to remainder multiply by remainder multiply by remainder. So 3 into 3 into 3, it will be 27 will be added to sum, right? Now here you can write temp equal to temp divided by 10. So you will get the number and you will get each and every remainder, and the remainder will be multiplied by 3 times. So you will get the cube of that remainder that will be added to sum. Now here you can just simply write the condition if the sum and number, so number is equal to sum, then you can say the given number is the Armstrong number, else we can say it is not Armstrong. So this is the very simple thing. We can do the same thing in our actual program. See, we already did the temporary equal to number. Now I don't need the reverse, so I'm just declaring here variable that is sum is equal to 0. Instead of reverse, I will just make it here, and that will be what? Sum plus is equal to remainder multiply by remainder multiply by remainder. And here I don't want the reverse. I will just check that if number equals sum, then you can say that the given number is Armstrong number. So very simple thing, and you can just make the changes over here. So your existing program, in your existing program, you need to just make the changes over here. That is sum plus is equal to, so we cannot make the space over here. Build and run. Now it is asking me for the number, right? So suppose if I'm entering the number 153, then it will say that the 153 is the Armstrong number. You can check another number, for example 6. Then 6 is not the Armstrong number. Suppose if you pass here the another number, for example 371, then it says that the 371 is the Armstrong number. How can I check that the 371 is Armstrong or not? So if you check over here on the paper, that is 371, then the cube of 3 will be 27, cube of 7, that will be 343, and cube of 1, it will be 1. Now if you make the sum of 1, 27 and 343, then you will get the 7 plus 3, 10 plus 1, 11 plus 1, 2 plus 1, 3 plus 4, 7 and 3. You will get the actual number. So you can say 371 is the Armstrong number, right? So very simple to convert any program into sum of digit to reverse, reverse to palindrome, and palindrome to Armstrong number. But the journey is not over yet. Now I want to check that the given number is a strong number or not. Now, how to find that the given number is strong number or not? First, I need to understand which number is known as a strong number, right? So, let me give you an example. For example, number is 145. So 145 is known as a strong number. How? Simple. You need to cut each and every digit, right? So factorial of this number, it will be 120. Factorial of this number, it will be 24. Factorial of this number, it will be 1. Now you can make the sum of this, that is 1 plus 24 plus 120. you will get the 145. It means what is a strong number? Strong number means factorial of each digit, right? I need to add here sum of factorial of each digit equal to original number is known as a strong number, right? So what I need to do here, very simple, I need to cut the very first digit, then I need to convert, then I need to calculate the factorial of each number. So very simple, let me save this particular program and I want to save it as a strong number. So very simple, I need to cut the number first. So I'm just cutting the number. I'm assigning to that is the temporary variable. Now, whenever you cut any number, your number will be available in your remainder, right? Now we need to find it out the factorial of remainder. So how to calculate the factorial? Very simple. Here you can declare the variable that is I. Now I need to use the nested loop over here. That is I equal to 1, I less than or equal to remainder. For example, remainder is 5. Then this loop will be run up to 1 to 5. Then what we need to do? Simple. Factorial multiply is equal to I. So you will get the factorial of that particular number. But whenever you start this, before this, you just need to make factorial equal to 0. Why? Because we need to find it out the factorial of each number. We need to make factorial equal to 1. Why? Because we are multiplying the numbers. So I am doing what? Here this particular code will do the factorial of the number, right? That is I equal to 1 to remainder and it will run up to remainder and factorial multiply equal to I. Factorial I am just initialize with the 1. Now once you get the factorial, then we simply need to add this factorial to some variable. So sum plus equal to factorial, right? So each and every time my sum will my factorial number will be added. If you want to trust this particular program, then my recommendation to you guys is to print the number first, right? So if you will get the clear cut idea that you are able to find it out the factorial of the given number, right? So I'm just writing here that is percentage D and I'm just printing the factorial. Now you can just write build and run. Now I'm just passing the number. For example, the number is 34562, right? So I want to just check the factorial of each and every number. So factorial of 2, that will be 2, right? Factorial of 6, it will be 720. Factorial of 5, it will be 120. Factorial of 4, it will be 24. And factorial of 3, it will be 6. Why it's starting from last? Because we are doing the modulo 10. So I'm getting the last number first. So factorial of 2 is 2. Factorial of 6 is 720. It means I am able to find it out the factorial of each and every digit, right? Now I just need to do what? I just need to add this factorial value into sum, and if sum and number both are same, then you can say that the given number is the strong number, right? And if not same, then you can say that the given number is not a strong number. Here you can simply remove a comment and then you can run the code, and now you will be able to get the idea. For example, if I am passing 146, it says that 146 is not a strong number. But if I am passing 145, then it should give me a message that the 145 is a strong number. Right? What I did? Very simple. I just assign my original number to temporary. Then until and unless my not temporary not becomes 0, I'm just getting the remainder. Now I'm getting the factorial of each remainder. Then I'm adding that factorial into some variable, and I'm doing this thing until and unless my temporary not becomes 0. At last, if my original number and sum both are same, then I'm announcing that the given number is a strong number, and else I'm just giving that the given number is not a strong number, right? So very simple. It is a, you can say that the concept of nested loop. Now I want to find it out the binary to decimal number. It means I have the binary number and I want to convert the binary number into decimal. Is there any different way, or how can I do this? So very simple. See, suppose my binary number is 10111010, right? This is my binary number and I want to convert this binary into decimal. So very simple, whenever you want to convert the number into binary, you first need to get each and every digit from the last. Then we just need to get the power of 2. So here you can say that a 2 raised to 0 multiplied by this, 2 raised to 1 multiplied by this, 2 raised to 2 multiplied by this, 2 raised to 3 multiplied by this, 2 raised to 4 multiplied by this, 2 raised to 5 multiplied by this, and 2 raised to 6 multiplied by this. One more thing, that anything multiplied by 0, the value will be 0, right? So we will not consider this particular value. So 2 raised to 6 is a 64. 64 into 1, so I will get 64. 2 raised to 4, that will be 16. 16 into 1, so I will get 16. 2 raised to 3 is 8, so I will get 8. 2 raised to 1 is a 4, so I will get 4. Now if you make the sum of all this, then you will get the decimal number. So 64 plus 16, it will be 80 plus 8, 88 plus 4, so you will get 92. So how to do this particular thing? Very simple. We just need to get the remainder first. Once we get the remainder, so let me write here, remainder is equal to number modulo by 10. So whenever you give the number modulo by 10, you will get the remainder. Once you get the remainder, then we can write here decimal is equal to decimal plus. Why? Because we need to make the sum over here. So decimal plus, now here you can write remainder multiplied by power of 2. Now what is power of 2? That will be 20, 21, 22, 23, 24, 25, like this, right? You can initialize your power 2 variable with power 2 is equal to, you can initialize with 1. Now very simple, you can write here number equal to number divided by 10, and you can simply, right, that is power 2. Now you can initialize every time that power 2 equal to power 2 multiply by 2. So what happens? See, it will be 1 first, then 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Every time my value will be multiplied by 2. So first it is 1. 1 into 2, I will get 2, 2, 4, 8, 16, 34, like this. Up to what time I need to do this? While my number not equal to 0. And at last, you can simply print your decimal. If you do like this, here you can check and verify. See, whenever you write remainder equal to number modulo 10, then it will get the last number. Now, this remainder multiplied by power 2. Power 2 is what? 1. Right? 2 raised to 0 will be 1. So 1 into 0, anything multiplied by 0, you will get the 0. But if the value is 1 over here, then you will get the value. That will be added to your decimal variable. And here you can simply initialize decimal equal to 0. So your decimal variable will be able to get the decimal number from the binary. So how to do this particular thing? Very simple. Let me save this program. That is a binary to, that is decimal. So definitely I need to get the binary from the user. So I don't want to write all these things. Here you can simply write integer number. Now we need a decimal number, we need a binary number, we need a remainder, we need a power 2 variable, that will be 1. Simple. Now we can ask to the user that enter any binary number. So user need to write the binary number over here. You can just get the binary number from the user. Now I just need to do what? While number, that is a binary number, not equal to 0, right? So I'm just writing here, while binary number not equal to 0. Now what I need to do? Simple, that is remainder is equal to binary modulo by 10. Now here you can write decimal equal to decimal plus remainder multiplied by power 2. Now what is power 2? Power 2 is my variable which has the value 1. So you can just simply write here power 2 equal to power 2 multiplied by 2. So it will become 1, 2, 4, 8, 16, 32, 64 and so on. And then you can simply write that is binary equal to binary divided by 10. Instead of binary, you can get the number also variable if it is required. Now here you can simply print your decimal. But before this, you just need to initialize the decimal equal to 0. So here you can write that the number is equal to, that is a decimal is equal to percentage D, and you can print your decimal number. Whenever you run this particular program, you will get an error just because this decimal equal to decimal. Here you need to make a semicolon. So here now you can run your program, and here you can just check that enter the binary number. Now here we will put the same number that we traced on the paper, that is 10110110. And whenever you press enter, you will get that the decimal is equal to 90. I need to check 1011010110. Yes, I did some mistake. That is what, see here. That is here 2 raised to 1 is not 4, it is 2. Right? So whenever you make 2, so 64 plus 16 it will be 80 plus 8, 88 plus 2, you will get the 90. Right? So 90 is the correct. 2 raised to 1 is 2. 2 raised to 1 is not a 4. Right? 2 raised to 2 is a 4. Right? So whenever you pass any binary number, it will convert your binary into decimal. You can check for the another number also if it is required. Now the question is little bit different. Suppose, sir, if I am passing 90 and I want to convert this decimal into binary, then what is the procedure? Very simple. See, whenever you have a binary number, then the base is 2. Whenever you have binary number, then the base is 2. Whenever you have a decimal number, then the base is 10. Remember, students, what I am doing? See, please see. Whenever you have binary number, then the base is 2, and that is the reason why we are writing here power of 2. Whenever you have a decimal number, the base is 10. So we will need to do what? That is the power of, that will be 10, right? So I want to convert the decimal into binary. So instead of modulo 10, you need to write here modulo 2. So I want to make the simple changes into this particular program, and that is a decimal to binary. Now the question is, what is your number, binary or decimal? My number is decimal. So I will get the decimal from the user. Now the question is, binary not equal to 0, not decimal not equal to 0. Now instead of binary modulo 10, we will make decimal modulo 2. Why? Because we need to convert it into binary. So instead of power 2, we need a power 10. So I will write here power 10. Instead of power multiply by 2, I need to write here power 10 multiply by 10. Why? Because we need a base 10. Instead of decimal, here we can write a binary. So we can write here binary equal to binary plus remainder multiplied by power 10. And here you can simply write that is the binary, that will be not binary. Here you can write decimal equal to decimal divided by 2. So very simple. Instead of modulo 10, you can write modulo 2. Instead of modulo divided by 10, you can write divided by 2. Instead of multiply by power 2, you can write multiply by power 10. And instead of power 10 multiply by power 2 multiply by 2, you can get the power 10 multiply by 10. And at last you will get the binary of the given number. and you can simply print your binary number. You can just check it is working or not. Now instead of instead of binary number, now I need to pass only decimal number. So whenever I pass decimal number 90, I will get the same result that is available over here. See, so decimal of 90 is equal to, that is 1011010, and here you can check 1011010. So it's a magic of base, that whenever you have a binary number, the base is 2. So you can multiply with the power of 2. Whenever you have a decimal number, the base is 10. So you can multiply with the power 10. Instead of power 2, you can multiply with the power 10. Now where you want to go? I want to go into decimal, binary into decimal, then I will modulo 10 and divide 10. Where you want to go? I want to go into decimal into binary, then I will go modulo 2 and divide by 2, right? So depending upon the requirement, you can use the different variable and you will get the output over here. So that's it from my side.